Hello and welcome to the video. We're going to discuss how to calculate the radius of curvature of a conical fretboard. But before we do, we need to address a basic question. What is the point of a conical fretboard? In order to understand why it matters at all, let's look at the simplest case. This is a cross-section through a traditional classical guitar neck. As you can see, the fretboard is flat. This makes building the guitar relatively simple for two reasons. Firstly, we can plane the fingerboard flat with no need to carry out any further shaping operations. Secondly, we don't have to worry about the string spacing changing between the nut and the bridge. The distance between the frets and the strings doesn't change. However, steel string guitars are normally made with a slight curvature across the width of the neck. This is known as the fretboard radius, and whilst it's very slight, it seems to make playing a little more comfortable as the neck follows the natural curve of our fingers. To illustrate how big the radius of curvature is compared to the width of the fingerboard, this is a typical guitar neck at the nut. And this is the radius of curvature of the fingerboard. It depends on the guitar, but typically you can fit more than 25 fretboards into the diameter of the circle formed by the fretboard radius. And if you did put lots of fretboards side by side, you'd form a cylinder. However, whilst the radius fretboard is easier to play, it does cause a slight problem. This diagram has been wildly exaggerated to illustrate a point, but the basic principle is valid. The only way the strings can stay a constant distance from the fingerboard is if the nut and the bridge have the same string spacing. Unfortunately, pretty much every steel string guitar has a bridge that's wider than the nut. Whilst this seems to make playing easier at the upper frets, it also increases the distance between the neck and the strings. On a real neck, the height increase isn't this big. Nevertheless, the further from the centre of the neck we get, the further the strings get from the fretboard. The effect also gets worse the bigger the difference between the nut and the bridge. So what's the solution to the problem? As you probably guessed from the title of this video, the answer is a conical fretboard, or more accurately a fretboard that forms part of the surface of a cone. In other words, if you take a large number of these fretboards and put them side by side, they'll form a shape that is part of the surface of a cone. This is the same cone viewed from the widest end. As you can hopefully see, even though the string spacing increases, the distance between the strings and the fretboard stays constant. This shape of fingerboard is also popularly known as a compound radius fretboard. Whatever you call it, the calculations remain the same.